All right, so now let's move on past the biological indicators and talk about the geomorphological one. And we're going to start with bankful channel width. We've already talked about how you measure this. The measure you use to determine the reach length is also the measure you use as the indicator in both snow-influenced and non-snow influenced regions. We recommend making this measurement at 3 locations, and in multi-threaded systems, you're basing it on the width of the entire active channel, not just the primary channel. Now, bankful channel width is an example of what we call an associated indicator. It is associated with longer stream flow duration. Within the Western Mountains, larger, wider channels tended to have longer duration flows. The smallest channels were usually ephemeral, like you can see in that photo. It is not a response. It doesn't change with flow duration, and it doesn't control stream flow duration like climate indicators do. So this is an example of an associated indicator. It was selected based on the improvements it provided to the method, so it's sort of a data-driven selection rather than these sort of conceptual linkages with response and control indicators. Do you want to point out that this pattern changes in the arid west? You typically have, very wide ephemeral washes, and you have narrow perennial headwaters in the arid west. So when you're near the boundary, you may need to, pay attention to how this indicator is playing out and affecting your classifications. We actually have you record this on 2 different places on the field form, and this is really for convenience. One is for where you're actually describing your reach length and how you got there. The later is where you have all the indicators compiled. This makes it easier for you to run the web application later. Again, the arid west method did not use any geomorphological indicators. Now we're going to talk about sinuosity. Again, this is another associated stream flow duration indicator. It's not a response or control. It was used within the non-snow influence portions. So again, we're mostly talking about California North Coast and Sierra Nevada foothills and scattered portions of Montana and Arizona and Colorado. It's an indicator in the non-snow influenced region, but it can also be used as a supplement anywhere. The way we define it, it is the ratio of stream length to valley length. So stream length is this blue line that's wiggling all around. The red line is how you get from the top of the reach to the bottom of the reach, as the crow flies. Fish swims versus crow flies. You can visually estimate this or directly measure it using a compass or a surveying tool. It's okay to estimate this in aerial imagery. That's sometimes a great way to do it, but again, you want to verify in the field. The way we score it is, again, ranked from 0 for very low measures to high. The lowest you can get is a ratio of 1. A straight line is a 1. And if you're, either a completely straight line or not too much wiggle, you get a poor score, whereas a highly meandering path will get strong. So it's above a 1.4. That's the minimum cutoff. These images here are segments from the National Hydrography dataset that happen to have ratios that correspond to these categories. During the training, a question was raised about how to measure sinuosity in a multi-threaded channel. When you're in a multi-threaded channel, you should focus your measurement on the primary channel where most of the water would flow through. This is typically the lowest elevation channel. So if you have a channel that meanders through a multi-threaded system, you could get a fairly high score for this indicator. Again, you record that score on the field form. Half scores are allowed. The arid west method did not use geomorphological indicators. Finally, we have climatic variables. We have precipitation and long-term mean annual max air temperature. And again, these are measured using using the web application. You don't have to do your own GIS. So climatic variables control stream flow duration. Precip governs how much water is available, how much runoff is being produced in the watershed. We look at May precipitation in the non-snow influenced regions, and we look at October precipitation in the snow influenced regions. Air temperature dictates how much evapotranspiration can occur, and we only use that one as an indicator in the non-snow influenced regions. Again, like I said, we use the web application, and the web application behind the scenes is using the PRISM package in R. The PRISM is, of course, a great national data set of climatic variables for the long term, and what the web application is calculating the long-term averages for both all three climatic indicators. You can record the outputs on the field form if you get them out of the web application. Again, climatic indicators were not used in the arid West. We have also supplemental information for the Western Mountains SDAM, just like we did for the arid West. It's not a formal part of the method. It's not required for making a classification, but it may provide additional evidence that supports a classification. And we recommend that they get measured at any point during an assessment. I'd mentioned this before, but there are indicators that are only used for classifying one of the two strata, and you can use them as supplemental information in the other stratum. And then in addition, we look at things like amphibians and presence of iron oxidizing fungi and bacteria. These are sort of the recommended supplemental information for this method. This is consistent with what's recommended for the arid West. So semi-aquatic amphibians and reptiles, you want to look for any different life stages for eggs, larvae, tadpoles, juveniles, adults, etc. If you hear frog calls but don't see frogs, you should note that on the field forms. Most species of garter snake within the Western Mountains are aquatic. Within the Western Mountains, there's a variety of pond turtles, mud turtles, soft-shell turtles I've listed, but I think they're not really all that common within the region. But if you see them, they're pretty good indicators that there's flow, or I should say it's good supplemental information about flow duration. Iron oxidizing fungi and bacteria, these are iridescent sheens or rust-colored sheens on the surface of stagnant water. You can distinguish them from oil slicks caused by either road runoff or natural oil seeps by you run a stick through the film, and if it breaks apart and doesn't reform, you have a biological film of iron oxidizing fungi and bacteria. If it just coalesces back together, it's oil. In some streams, particularly those affected by mines or certain groundwater discharges, you can find them in very high abundance. Again, any supplemental information you just describe in the field form, and know any photos you might have taken.